So let's see, who's got their cameras off and I can ask a question too. Jared, can you tell me about what a class is?
So the class is scrolling back up to my notes.
Sure.
It's an object constructor or a blueprint for creating objects.
Okay, good. So it's a way of describing what you want a given object to look like. So
Right.
so you have classes, and then what do you do with classes?
Then you can make objects of that class.
Right. So so Python calls them objects. Is there maybe a more general term?
Instance.
Yeah. So you create a class, which is like a blueprint or a prototype or a form or whatever, and then when you can create a whole bunch of instances that have the same shape as that class. So why would you want to make a class?
It makes it easier to create those instances that all have similar attributes.
Yeah. Yeah, so it makes it easier. It also makes your code less repetitive. If you're creating a whole bunch of objects or things that kind of have the same basic layout, instead of individually filling that stuff out for every single time, you can abstract that out into a class, keep that in one place. Yeah, so that's the general. So it exists because of this more general principle called try, don't repeat yourself. So this is, if you find yourself repeating yourself in your code, then it's probably time to think about refactoring. Okay, so that's classes. We also talked about test-driven development. So Deb, your camera is still off. So can you tell me what test-driven development is? Hey Deb, are you there? All right, I'll have to pick on her later. Let's see. Well, everyone else is being good. So any volunteers? Would anyone like to tell me what test-driven development is?
You just write the tests before you write the code. So all your steps, you're going to write a test first, and then write the code to make it go true.
Okay, right. So it kind of turns the typical way of doing things on its head, where instead of writing code and then I write tests after I write the code to make sure that it's working, you start by writing tests. So the cycle for that is called red-green refactor. So you write a test that describes some bit of functionality that you want in your code, and then you run the test and it should fail. That's red. And then you go and write just enough code to make the test pass. So it will be green. And then refactor is just kind of take another look at everything in context and see if there are any changes that need to happen. So that's just the basic cycle that happens over and over again. All right, are there any questions about test-driven development or classes? Okay, so we saw last week we did test-driven development using Jest, and this week we're going to use instead of using Jest, which is a third-party library, we're going to use unittest, which is for Python, and it's part of Python's standard library. So if you're curious, actually let me share my screen. So if you're curious about Python standard library, which has a lot of cool stuff in it, so if you want to explore that, I would highly recommend this. It started out as like blog post. He started doing it with Python 2, and then this is the Python 3 version. So if you do a search for it, just keep that in mind. There's a Python 2 and a Python 3 version. But he goes through and he just kind of talks about and gives some examples from some of the, not even all, but some of the modules in Python standard library. There's all kinds of stuff, you know, data structures, which we'll talk about a little bit, arrays, heaps. There's all kinds of stuff for file processing, you know, cryptography, networking. We'll, in a few weeks, we'll be using this this library to build a server from scratch. So there's all kinds of stuff that Python gives you for free. So it exists in the standard library, but you can't just use it directly in your code. You have to import it. You don't have to download it or anything like that, but you just have to have an import statement at the beginning. So if I want to use the stuff that's in this string library, I have to import string at the top of my file. So it's a part of, you know, it's not a part of the core Python, but it's usable without downloading anything. It's not a third-party module. Okay, so what we're going to do now is we're going to go over the credit check, and I'm going to do it in I'm going to do it as a class first, and then I'll walk through a functional approach after that. But we're going to do it as a class, and we're going to use Python's unit test library to write unit tests and do it in a test-driven development style. So here is the documentation. So Python has its own official documentation, which is very good, but sometimes can be difficult to use or understand in the beginning. But just to be aware that, you know, Python itself does have official documentation. And here's the official documentation for unit test. Unit test is part of the standard library, so you can use it. You can use it in your code just with an import statement. And this unit test framework has a whole bunch of capabilities, and you can read about that here. There are test fixtures, test cases, and so on. We're gonna focus this on the test case. So a test case is the individual unit of testing. It tests for a specific response to a particular set of inputs. So this should, well, it will look familiar. So even though Jest is a third-party library and it's for JavaScript, basically all testing frameworks kind of do the same stuff, right? They're gonna run whatever function you have, and they're gonna check if whatever you say is supposed to happen happens. So there's only so many ways you can do that. So one difference between Jest and unit test is how the code itself is organized. So Jest uses functions, and unit test is object oriented, so it uses classes. Sorry. So here's how you have to import unit tests. It's from the standard library. So you import unit tests right here. You don't need to download it. And then you create a class called whatever you want your test class to be called. This can be called anything. And then there's something happening here that we haven't talked about. Does anyone have a guess what that might be?
I think that's inheritance, right?
Yeah. Yeah, it's inheritance. So we'll talk about inheritance later, but I'll show you an example of what that looks like as well. But so this basically means we're creating our own class, but we want to use basically as our base, we're going to use all the stuff that this built-in test case class gives us. So we can add our own stuff too, but we're also getting a whole bunch of other stuff for free. So we're just, slightly customizing or adding to this unit tests base test case class.
So test case is something that comes in along with unit test, is that right?
Yeah, so notice the dot notation. So unit test dot test case. So let me, we can take a look around in the source code in a second when we start. I open up VS Code, so we can see what some of this stuff actually looks like. And then the basic structure here is you write your tests, and then tests need to be prefixed like this so that internally this is how these tests are discovered and run. So you have to call your methods test underscore and then whatever else you want. So you write your test methods, which are going to be called test underscore whatever. And then you will perform whatever logic you need to do. In a simple case, you're going to run some function, and then there's a whole bunch of these assert methods. So just like in jest, right, we had a whole bunch of assert methods like to be equal, to be falsy, whatever, and there's a whole the same thing exists here, right? They all kind of do the same thing: assert equal, assert true, assert false, and we can take a look. Right. So if we look down here in the documentation, the test case class provides several assert methods. So you can just take a look at this. So assert equal, assert not equal, assert true. There's a whole bunch of these that you can use. So we go here, we import unit test, we subclass unit tests, test case class. We write our methods, test underscore whatever, and then we will use an assert statement to check whatever function that we're running has the value that we're expecting. And then at the bottom, does anyone have any guesses for what this is?
So I think I know there's like a convention, but essentially when you run a Python script from the file itself, it will be aliased as main, and if you execute it as though it were an import from a different script, it will have a different name. And so essentially this is a way of running this individual file only if you're executing it as a standalone script, not as like a subscript in a different file, something along those lines.
Yeah. So that's exactly right. So it's so this line isn't strictly necessary. You don't have to have it, but it's a way of controlling when it gets executed. So as you said, if you run this file, if I do Python space whatever this file name is, then this file name will run. So the name will be main and this file will run. But if I import this test somewhere else, if I import this file to another file, this part won't run. So why might you want to do this? Well, I guess back in the day before the unit test library, this is often where you would put your unit tests. So you'd write some code, and then you could write a bunch of kind of like unit tests, like assert statements, or kind of like what we were doing with the spec files. So if you put that here, and so if you ran the file directly, then all the test cases would run and you could see what's going on. But if you were actually using it in another file, like as part of the larger application, then the tests wouldn't run. So you'll see this. It's usually not strictly necessary, but it's partly just a convention. But yeah, just so you're aware of that. So if name equals main, and this just means, am I running this file directly? If yes, then go ahead and execute unit test.main, and this will run all of the tests that you have. Are there any questions about that? All right. So let's go ahead and look at credit check. So we've got credit check here, and we can see from the README that we're gonna have to do a few things. So it looks like we'll get some kind of number, and if we look at the spec file, looks like we're getting a string. So we can tell from the test we have that our input is going to be a string of digits, and we're going to then, the directions could be clear, but we have this string of digits, and then every other one starting from the right will double, and then after that we will, if the number is 10 or greater, we'll add the digits together, and then for the final step we're going to add everything up and see if it's divisible by 10, evenly divisible by 10. So there's a whole bunch of steps here. So now that we understand the problem, we should start coding immediately, right? Because we want to get this done as fast as possible.
No, we need to write out the steps first, like pseudocoding.
Okay. So can you help me pseudocode?
Yeah, a little bit. I'm,
CDB?
my camera's off because I'm eating breakfast. I don't want to be
Sure,
rude to
sure.
everybody here.
That's
So,
fine. That's fine.
when I finish stuff in my face, I'll turn it back on. Yeah, so first off, we want to determine, like I said, if it was a string. And then the first line is, let me pull it back up, the multiplying. Far away. So first line, we want to figure out how we're going to multiply every other function. So what it's going to
Okay.
take to do that.
So what is the first step?
Where's that? So the first step is the right digit and doubling as you move to the left.
Okay. Okay, so something like that. And
Okay. And then from that line, we're going to look at every other digit gets doubled. So we'd be able to jump over the string.
Sorry, so what's the next step?
That every other digit is going to get doubled. So we need to be able to jump over the string, jump over the numbers.
Okay, so
Increment.
let's assume that we've doubled every other digit. So
Okay.
what's the next thing we have to do?
Then we have to add, third line is add up all those numbers over 10.
Okay, so I guess 10 or over. Okay, and then what's the next step?
We're going to, the third line, we're going to add all those numbers up to get a total of all the individual digits.
Okay. Okay. So I think this is probably, this is good as a general overview of what the problem is. There's one other thing we could think about. So we have to start from right to left here. So, you know, it's, and it looks like all these other operations will also basically be right, starting from the right to left. So it doesn't tell us explicitly, but we might think that reversing this could be useful. So put a question mark there. So we could maybe reverse whatever we get, and then we'll double every other digit, and then we'll add digits over 10, and then total all of the digits. So what should I do with these chunks?
You could turn them into methods, you know, each one's its own method inside the class.
Okay, I think that's a good place to start. So let's start by writing the class. We'll do class credit check. So we've talked about methods, so we'll skip any we'll skip this step for now. So let's start writing out the methods. So I'm just going to do something like this. And what should I probably include here by default, unless I have a reason not to?
Self.
Self.
Yeah. And what is self?
It's the reference to the instance that's happening.
Yeah. So this will be whatever instance that we create from this class. So any given instance. All right, and then the next method will be double every other. Let's do something like that. And again, we'll start off with self. And then the third one is add digits. So and then the last one, let's see. Okay. So I think this is a good start for the methods we might want to have in our class. Again, we could do all of this in one giant function or one giant method, but I think it's probably best for the sake of clarity and unit testing to break these up. So let's say we have our 4 functions here. What about attributes of this class or instances from this class? So classes usually have 2 kinds of things. They have methods, and then they have properties or attributes or whatever. All right, so there's data, and then there's actions. So we have our actions. What data should this class have?
It's gonna be the number no matter what that gets passed in. On
Right.
the init, you have to create the init function, the
Okay.
init method.
Yeah, so I think it would make sense that when we create an instance of a class, that we start off with the number that we want to check, because that's going to be, you know, unique across instances. So that's something, you know, it doesn't, you know, strictly speaking, it doesn't have to be unique, but you can think of it as being unique. So any instance, that's really the one thing that's going to differ from instance to instance. So we'll put that as an instance attribute with def init. And can you tell me what init does?
It's everything that runs when you first create an instance of this class.
Yeah. So this will be basically any setup you want to do when you create an instance of the class. This is where you're gonna want to put stuff. So typically that's going to be creating instance attributes, but you can also run other functions and do other stuff. So self.digits is digits. Okay. So we have this credit check class. We're going to, when we create an instance of it, we're going to give it, we're going to start it off with whatever digits, and then we have these 4 methods we can run. So I think this will probably be enough to get us started. We can always change things later. All right, so let's, if we're doing red, green refactor, we should start by writing unit test before we do anything else. So I'm going to do, you can call this file whatever you want. I'm just going to call it test.py. And let's refer to the documentation just to remind ourselves what we're supposed to be doing. So here's a basic example, very handy. So we'll import unit test, and then we'll create a class that who's, that inherits from unit test's test case class. So import unit test, and then class, and I'll call this credit check test. And here I'm going to inherit from that test case. So I can do this here. Sorry. So an alternative way of importing this would be to do, instead of import unit test and then accessing this as unit test.test case, I can do from unit test import test case, and then I can just do that. So either of those will work. Okay. So I'm inheriting, so my custom class is inheriting from the built-in test case class. And you got to do some other things. So one, we'll have a method. Let's just start off with one, and it has to be called test underscore something. So def test underscore, and then well, what test should we run? Maybe that we can, if we create an instance, there's a self.digits property, something like that. So test instance as digits. And then we're gonna pass in self. And then I can't run this directly because it's in another file. So how do I run this credit check.py inside tests.py?
You
Do
need
the import
another-
statement. Sorry.
Yeah, import statement. So we'll do from credit check import credit check. So what's the difference between these two credit checks?
One is the name of the module and one is the name of the function or
Yes.
the class.
So which one is which?
The first one is the module.
Yeah. So this is the name of the module or the file, and this one is the name of the class or function or whatever that I want to use. So now I can do this. I can do credit check, and I can create an instance, and I'm gonna copy from here. And then what's the next thing I need to do?
You'd need to call the methods in order to essentially do the calculations and verify whether it's returning 0 or 1. Oh, I'm sorry, for just checking the has digits, it would be essentially just calling to verify if it has the attribute of
Yes.
the digits.
So how do I verify a value?
Use you would use the type method.
I think you could use self.assert true, and then whatever you pass in there, you're testing if it's true. So it would be like cc dot whatever the property name is dot type. I don't know the exact syntax, but equals string.
Yeah. So there's a number of things we do. I just wanted to get at, we have to write an assert statement. So there are a few things we could do. We could check the exact value. We could check the type. So yeah, so those are all good ideas. For now, I'm just going to check that it's equal to this exactly. So self.assert equal, and then cc dot digits, and okay, so I think we have a test case written. So we go back to the documentation. What's the next step? Looks like we need to call this unittest.main method. I'll just copy paste that. Oh, so that's why they just import unit tests. That's fine. So let me redo it. So there's a few ways we could do this. So what's the problem here?
You're only importing that one test case property.
Yeah. So I'm not importing unit test itself. So when I try to access unit test, my linter here doesn't know where it's coming from. So I could just import unit test again. So that will work, and that's fine. But then you're kind of like, I'm importing the whole thing, and then I'm also importing a specific thing. We can also do that. So we can import a comma separated list of things we want to import, and then we have to change this to just main. So this also will work. I would recommend just following the documentation because it's easier, but just to show you, this is how imports work. All right. So how do I run the tests? Python test.py. And then here's my output. So I guess this is not very good TDD since we passed our first test. We should fail it first, but that's how it goes. Okay, so the output here So this, you get one dot here. So a dot is a good thing. That means your test passes. When you get more tests, we'll see more dots. Then it'll tell you how many tests you ran. And then if there are failures, it'll give you information. So the specific display is a little different from Jest and other frameworks, but again, it's going to tell you what tests you're running, and if it fails, it'll tell you what failed. So it all kind of works the same. Another thing you can add, and probably should add, is a doc string to your tests. So we have a method name that's, I guess, fairly descriptive, but we could add a little more. You could do something like something like that. You can run that. So this is, documenting what the test does. This is for you and your future self and other developers who may be interacting with your code. Okay, so this is the basic idea. We go back to our credit check. So let's start knocking out some of these things. So let's start with reverse. So I should say we have some design decisions to make here about how we want this class to work. And at this point, it's, there aren't really any constraints that we have because we're not going to really be using this anywhere. So one question would be, what happens when we create an instance? So one option is, as we have here, we just assign this digits attribute to the instance, and that's it. And then if you actually want to use it, you have to run all of the methods in whatever order it is necessary. So that's one way of doing it. Another way of doing it is that in the init method, we could run like a function that runs everything. So when an instance is created, then all of the functions run, and we have access to whatever property or properties we decide are important. So if we want to know, is this actually a valid, we create an instance property called isValid, and then that could be true or false. And then as soon as we create an instance, we can immediately access that property. So that's another way of doing it, where it's kind of, as soon as we create it, everything runs, and that's it. So there are different use cases why you might want to do one or the other. Another question is, so we'll see this a little bit more clearly when we look at a functional implementation, but this is the information flow is like a pipe. So we talked a little bit about pipes. I think I mentioned pipes when we were talking about the command line in the first week. Does anyone know what pipes are?
You mean the or statement?
Yeah, so in JavaScript, yeah. In JavaScript, a pipe can be or. So let me just, on the command line, you can actually string together a whole bunch of commands and use pipes. So if I do something like echo hi, and I do that, it prints hi. But I can do echo hi and then like that. So what I'm doing here is I'm saying execute this command, which is, basically print hi to the terminal. And then whatever this outputs, that's going to be input for this next command. And WC, it doesn't matter what WC is. It's like, it counts the lines and words. So it doesn't really matter what this is, but it's the way of chaining together a command. So the result of the first command is the input for the second command, which then produces output, which is then input for the third command, and so on. So there's this just chain of inputs and outputs. So that's basically what's happening here, right? So I get some input, I reverse it, and then I pass that on to this double every other. That runs something that produces output. That output is then input for this add digits, and so on. So we could ask the question, what do we want to do with all of these intermediate values that we create? So one option is that we preserve them. So again, this would depend on your use case, but you might want to create a whole bunch of instance properties that are the result of all of these. So after you completely, run everything in an instance, you have access to all of these other properties. So that's what we're going to do, even though there's not like a real specific reason to do that for us, but just to show you that you can do that. So we're going to end up having a whole bunch of other instance properties. We'll have one for the reversed input, and then the doubled, and then the added, and then whether it's divisible by 3. So I'm going to go ahead and write another test case that will check that. So def test. I'm just going to sum up all these, but all I'm just going to copy this line. And again, if you find yourself copying stuff, probably indication that there's something you're doing wrong. And not going to talk about it right now, but there is setup. So if you look in the documentation and you want to play around with it yourself, there are these setup and teardown. So this is part of what a fixture is. So a test fixture. It's basically, instead of having every single test be completely isolated, you can, if there's common stuff you need to run a group of tests, you can set that up. So setup, you can take a look at that, but basically it would probably be a good idea to create like a single instance of a class that we could test on this stuff, but that's fine. So now we're going to do self.assert not is not none. Let's try that. So self.assert is not none. And then we'll do cc dot. We'll call it reversed. Let's try running that. Okay, so we get an error. We can see the output. So dot is a successful test. So F is a fail, E is an error. So we're getting an error because it doesn't have the attribute. So that counts as a failure. So we're red now. Let's make it green. So here we can do self.reverse equals, I guess this will probably end up being an array. So we'll do that. Let's try running the test again. And the test passes. All right. And I'm gonna, I guess we'll do one more. So self.assert is not none. And then we'll do doubled. Run this. Failure, 1 error. So we got this error. So because it's basically the same thing, I'm including it in this one test. We could also write actual separate test functions for these. So I'll go here and I'll do and let's say this should also be an array. So now our tests pass again. So again, we could keep doing that one more. I'm gonna kind of skip ahead. And I think probably this is a good time for a quick break. So let's come back at 9 o'clock and we'll continue. All right, so share my screen again. Okay, so here we are. We've figured out, we've kind of modified our original plan a little bit. We've added some more attributes. We'll go ahead and add self.added, something like that. And then is divisible by 10. So that sounds like a Boolean to me. So that is equals. We'll just start off with false for now. Okay, so now we know that when we're done. So another thing to think about is we don't strictly have to define these here, but it's usually a good idea because, again, in terms of code readability, it lets whoever's looking at this class know immediately that these are going to be the attributes. So we could just define them all in these functions, but in terms of readability, this is usually preferred. Okay, so I have all these properties. So let's start looking at the implementation of the methods. So reverse input. So we have a string of digits and we want to reverse that. So let's write a test that fails first. Input, something like that. And we'll do self.assert. Yeah, we'll try doing assert equal. So cc dot first. And that will be an array. And I don't want to write all these numbers out, so I'm just going to do something real quick. So that will fail anyway. And then I'll copy the correct input. All right, so we'll do this. And let's run the test. So that fails in part because we haven't actually run anything. So we should actually make sure we're running the method. So cc dot reverse input. So we'll run this test again. It will also fail because we're not modifying that at all. So now we will change what's going on here. So reverse input. So I'm going to use, there's a few ways you could do this. I like list comprehensions, and list comprehensions are considered very Pythonic. You may have heard this term, Pythonic. Is something Pythonic or not? It's a deep philosophical question you can start asking yourself all the time. So list comprehensions are very Pythonic, which usually means good. So the list comprehension will be something like digit for digit in self dot digits. And again, we can access this property because this is part of the instance. So we'll be able to get this from within this method. So you don't have to pass it in as a parameter. We could set it up we could set it up that way, but the way we're doing it, because we've made this somewhat arbitrary design decision initially, this is how we'll do it. And then in order to reverse it, we can use Python's very concise slicing syntax. So -1. So these first two blanks are default values. So by default, it will start at the beginning and it will go to the end. And it will, -1 means it'll go backwards. So we'll assign this to self.reversed. And now let's run our test. And that fails. And now I'm just going to be very lazy, copy this, paste this in here. And so, obviously we're cheating a little bit here. So you might want to not use such a circular process, but that's fine. So now we have an array that is reversed. So we can just kind of see it 0, 4, 2, 5. So this looks like it's reversed to me. So now that part is done. So once we reverse it, we need to double every other thing. So this will be a little more complicated. So there's a few ways we could do this. We could use a for loop and so on, but I'm going to use a list comprehension, and we can talk about whether that ends up being a good idea or not. So we need to double every other one. So I'm going to create a list comprehension. And remember, the output of this one is going to be the input here. So what we want to do here is check if every other value is even, and then if it is, we're going to double it. So we either want this to be an array where we don't change it, or we double something. So we're going to need a conditional. And you can include conditionals in list comprehensions. It makes it kind of longer and arguably harder to read, but we'll do this anyway just to show you list comprehensions. So we will do let's say we want to keep things as strings for now, ultimately. But when we actually do this operation, we're going to need to convert it to an integer. So int digit times 2. Where's this? Times 2. Yeah, so string int digit times 2 for digit in so there's another question here. How do we make sure that we can determine if something is every other or not? We'll have to get the index, and we can use that. You can get that using enumerate. So when we're talking about for loops, there are different kinds of things you can loop over. One of them is an enumeration. So enumerate self.reversed. Okay. So the syntax here for conditionals is a bit weird. So we'll do this if sorry, so this is one reason why when list comprehensions start getting complicated, you may not want to do them, but I want to show you this just again to show you list comprehensions, and two, to show you maybe this is not a good idea to use, maybe not. Okay, so we'll have to put the conditionals here. So we have our what we want to return in the case this is true, and then we have what we're actually looping over. So if I modulus 2 is 0, then we're going to return this. Otherwise, else we'll return the digit. Actually, before we do that, we should be writing a failing test. Let's write that failing test. Def doubled is something like that. So run. We'll actually need to run both of these. And once we run that one, we can also run double every other. And then once we have that, we should have this property. So self.assert equal cc.doubled. And that should equal something. I'm just going to copy this for now. And it should fail, and then I'll copy in the correct one. So let's run the tests. Okay, so we have a failure. So we have pass, fail, pass, pass. So test doubled every other. It's telling us that this is the test that has failed. And let me try adding a doc string here. I'll run it again. And notice right here that I get this, the doc string shows up. So that's handy for you, and again, for other developers you'll be working with. So you have ideally a descriptive test name, and then you also describe the test, so when it fails, people can see exactly what it should be doing. And then, so we have some more explicit output here. So second list, so it's just giving us more detail. Second list contains 16 additional elements, and so on. So this is what we, so this is like the diff. This is the difference between these two things. Okay, so we have a failed test. So now let's try to make it pass. So we already wrote this. And let's set this equal to self.doubled. And let's see if that works. So we'll run the test. Four. Oh, looks like I'm not gonna be able to entirely cheat here. I'll do what I can. So 18, 18, 7, 6, 18, 8. And this will be 0 still. This one will be itself. And then this one should be 2. and then 4, and then 10 and 5. We'll leave that as right. We'll see. Okay, so that passes now. Okay, so now we have this doubled every other thing. So now we run this, we can get the reverse, then doubled every other, and now we need to add those digits if they're basically if they're 10 or greater. So you can also use a, well, I guess let's write the failing test first. Def test. Yes, it's greater than or equal to. All right, and we're going to need to include all this stuff because these are dependencies. And then we can run the actual method we're interested in. So cc dot added or add digits. And we'll do our assert statement. Assert equal cc dot added, and that should equal, we'll start off with this, even though this is wrong, and run the test. Okay, and this fails because we start off with an empty list. So it's failing, so let's make it pass. We'll do self dot, well, let's write the list comprehension first. So here what we're gonna need to do is we're gonna need to go through the array, and then we're going to check, basically, since these are strings, we preserve them as strings. We could also, if we converted them to digits, that would also be fine. We could just do a different test, but I kept them as strings. So we will test if the length of the string is greater than 1. And if it is, then we'll split it and then add them together. So let's take care of the for loop part of that. So, so for digit in self dot doubled, and then let's take care of the condition. So if len digit is greater than 1, so we have this condition, and then so if it's greater than 1, we'll do something, otherwise we'll do something else. So if it's greater than 1, then we're gonna have to change it, otherwise we're gonna keep it the way it is. So here we can just have the digit. So we're gonna loop over everything, all of these digits. We're gonna check if the length of the digit is greater than 1, we'll return one thing, which we haven't written yet. Otherwise, we'll just keep it, we'll just return digit. So what do we want to do in case the length of the digit is greater than 1? Let's, we'll split them apart basically and add them together. So we'll do int, we'll convert this into an integer. So we're going to add these two things together. Are there any questions about this? I know the list comprehensions are.
I just had a question about list comprehension. So it looks like it's just saving you, like setting a new list variable, you know, like instead of doing this, it looks like you could set a new list variable, do the loop, do the same if else branch, and then just append to that new list.
Yes.
Like list comprehension just saves you the new list and the appending.
Yeah. So it's so once you start getting longer stuff like this, I think the readability starts suffering. I think it's very handy. So I think this example,
Yeah.
I think this is a great example of using a list comprehension. These ones, maybe not so great, but people definitely like using them. And it's also just a way, people like doing things in one line. So if you use the for loop, it takes several lines.
Right.
Not that, one-liners are necessarily a virtue. Oftentimes that's a bad idea from the readability perspective. It's possible, I'm not sure, but that list comprehensions are slightly more efficient than doing a for loop and appending.
Mhm.
But that probably depends on all kinds of things. But yeah, there are a few ways of doing what we're doing here with the list comprehensions. I mean, there's also map, so we could be mapping over. Okay. And the syntax is a bit weird, but it's good to be familiar with at least the basic use case for list comprehensions, like the basic syntax. All right, so let's assign this to self.added, and let's try running our test again. Okay, we have a failure. All right. So I guess I'll start going through here. This should be 9. Uh, 9.
The 16 characters in that output, is it condensing it for you in the output down there?
Yeah, I'm sure there's a way to change that setting. I don't know off the top of my head. All right, let's try running. Still does not. Oh. Yeah, so now these are, we go through and delete these quotes. Sorry about this. Tedious. Let me double check. So
It only took the quotes off the ones that actually got added.
okay, thank you. So let me also convert this one. Thank you. So now our test is passing. So we have this, and the last step is to check. We'll add up everything and then check if it's divisible by 10. So we'll write that test. Can't really keep all of this stuff. We'll do cc dot. And self dot assert equal. And we'll do cc dot is divisible. And that should equal true. I'm sure there's like an assert true. So let me just try doing that instead. So, assert equal, I mean, you can basically, this is the most general one. You can kind of do anything you want with this, but these are the more specific assertions. So I'll run this. It is false. It's false because we set this false by default. Okay, so now we'll try to make that test pass. And again, there's a few different ways you could do this. We could, have like a total variable, and then we could loop over everything and add 1 to the total, and then divide that total by 10. We can also do, let's do divisible. Let's do not a very good name, but there's also a higher order function we can use called sum. So sum is like a reducer. So in JavaScript, we have map and filter and reduce. Those are kind of the 3 big higher order functions. Sum is like a special case of a reducer where it takes a whole bunch of stuff. So map takes an array and then it returns an array of the same size. Filter takes an array and returns, potentially a smaller array. Reduce will take an array and return one thing. So sum is a reducer. It takes a bunch of stuff and it gives you one thing. So sum, and we'll pass it self.added. So that should give us a number, and then we'll check equals 0, and then self dot is divisible equals is div. Don't really have to do that extra step, but whatever. So let's try running this test now. This fails, so false is not true. Let's see. This should be true. Let me try. Try going back here. So sometimes you get better output if you do assert equal. Because if I do assert true, it just gets, I just get true or false. But if I want to actually see what the output is, let's see. Oh yeah, it's actually false. Never mind. Let me.
You need
Yeah. If anyone has an idea. 74. That's not right.
I think the doubled, it looks like we started at the wrong digit. I think the last digit should be 10, not 5. I think we doubled it starting at the check digit, and you're supposed to skip the check digit.
Thank you very much. So that's going to make all of our other tests fail. But
I'll post in the chat what the string or the list should be.
Thank
I think
you.
this is what it should be. And then so the first one is the check for test doubled is every other, and the second one is test add greater than 10.
Thank you. Test double. All right. Share screen again. Okay, cool. Thank you very much. And then let's add this modulus 10 equals 0. And that passed. So again, we could definitely write lots more tests here. And then I think you're actually supposed to return a string, right? A specific string. But you can just write another method for display called display or something like that. Actually, we'll just do that. So def self return you do something like this if you actually wanted to return the output. But this is the basic idea. Are there any questions about unit test library or test-driven development or this solution?
I had a question about like if JavaScript, you can write classes in JavaScript.
Yes, yeah, you can.
Okay.
So that feature was introduced, I think 2016. But yeah, you can do that. It's, you know, if you get into the weeds a little bit, technically, it's not really, it's not a class in like the official sense. For example, you can't do multiple inheritance with JavaScript classes. But it's part of JavaScript's prototype inheritance. But the short answer is yes, you can write classes in JavaScript.
So Chad, this is very helpful with the video will be, I guess, be very helpful with this unit testing because I need to practice with that. I just have a suggestion. When you do the demonstrations,
Yeah.
Is it possible you could do a Python and JavaScript version with the challenges? Is that possible?
Python and JavaScript version of the challenges.
Yes.
I mean, I couldn't go. I wouldn't have time to go over them. It's possible that there could be solutions. I could post solutions at least for some of them. But right now we're really focused on Python. But
because I would like to
yeah.
see the testing for the JavaScript testing. I mean, that would be helpful also, but I understand you said, I guess, based upon the schedule, you don't have the time.
But we will be going back into JavaScript more towards the end of the, like the second half when we start doing React again, and we'll see jest testing then as well. But the basic idea, I mean, the specific, like the specifics of jest or any other testing framework, I mean, you can just read the documentation and see what it does. What you should be learning now is the concepts. So, there are a lot of similarities between, even though, jest is for JavaScript and it's a third-party module, and unit test is for Python and it's part of the standard library. There's only so many things you do when you're testing. So you basically will run whatever function you want to test and then check that that returns or does whatever you expect it to do. So that's just the basics of how any testing library is going to work. In terms of like how you use tests, the process, using test-driven development and making sure that you're making your methods, modular, or thinking about modularity and purity and things like that as you're developing, rather than just having one giant function, which you could do, and there are use cases, but it makes it harder to unit test. So just thinking about all of these things is what you really should be learning right now. And then the specific details of any given implementation or framework are really, that's just kind of something you can look up. Okay.
Yeah, I do have one question about the syntax of that test. If you go back to the test.py thing, for some reason my brain's not working how this should work, but obviously all these tests are set up to be very, very specific with a very, very specific number. You would just create an instance variable that you would change, that you would feed into if you wanted to be able to test different strings, because obviously this whole testing is set up with the 55418. So you would just change that over to a variable and create an instance variable to feed it into it, right?
Yeah, so there's a lot of different ways you could do this. So the way we're doing it right now is kind of inefficient. So what you'd actually want to do probably is use a test fixture, and you could set up a whole bunch of instances. For example, you create like 10 instances and then just run the same check on all 10 instances for every test. For example, that's one way you could do it.
And to do that, the test fixture have to be outside of the class then?
No, it would be inside the class. So there's different kinds of, we didn't go into the details of this, but you can read the documentation. So there's setup, there's also setup class. So setup will work for basically, it'll run this method every time you run a test, and setup class will kind of run that when the test class itself is initialized. So if you want every test method to have some bit of information, which in our case, this is probably what we want to use. You create a whole bunch of instances in this setup class, and it's telling you how to do that. So this is a class method. We talked about static methods. There's also class method. This is another decorator. You don't really need to understand what that means exactly, but you can use it. So we would do something like copy that, go in here. And then we would do ls dot cc1 equals credit check, blah, blah, blah. And then you can do something like two equals, and then, for example, you could run this a whole bunch of self-assert equals for all of the instances that you have.
But on the testing side, then you still have to manually figure out each answer then, right? As it gets more and more complicated, you would need to do the math. And so there's no way, like,
unfortunately,
there's not something I'm missing that you just write the program twice then if you had to do it all for you. So
yeah, unfortunately in this case, it's kind of a pain. And again, like you saw me basically cheating, where I kind of like, I knew what the answer was supposed to be. And so once I got it, then I could copy paste it. But ideally, yeah, you would, I guess, be deriving the correct answer from somewhere else.
Yeah, I guess it makes more sense when you, like, maybe not the first time through, but like you said, if you were gonna do updates to the program to ensure you didn't break it by running all this you had set up. So it probably seems more laborious now, but 6 months from now, it probably makes more sense why you did it.
Yeah. Yeah, it's definitely, and there's also a, I was actually just, I didn't know about this before. Maybe I should have. So I was, last night, actually, I came across this and I thought it was pretty cool. I was thinking about introducing it, but I haven't actually used it yet. So I want to play around with it before I introduce it. But it's a testing library that will basically it's kind of like generates edge cases for you. So if I know that, for example, I have a function and it is supposed to return like a float or something like that. Hypothesis, rather than specifying individually like every single number that I want to test, I can use this and it will basically generate a whole bunch of numbers for me. So yeah, I'll probably play around with this in the coming weeks, hopefully. But so yeah, there are tools again. So this is just Python and JavaScript. There's a huge ecosystem of third-party stuff, and oftentimes the problem that you're having that you want to solve has been solved by someone who's, you know, smarter than you and better at programming than you. So something like this, rather than having to do this from scratch. I don't know, does that help at all?
No, it answered the question. I just, yeah, just a laborious process no matter what to set it up.
Yeah,
There's no quick fix for it.
Yeah, test-driven development is very time-consuming. The idea is that it saves you time in the long run because it makes your code less brittle. But upfront, it definitely costs time. And again, I'm not pushing test-driven development as an ideology, but I am pushing you have to write tests. Any more questions? So this has gone on for a little long. So I just want to show you, I'm not going to code it out, but I just want to show you a functional version. Maybe I should get rid of, anyway, because I have some additional, I'll leave that in for now. So here's a functional solution. Maybe I should delete this one for now. All right, so let me try running it. So what I've done here is basically the same thing, right? So I have reverse digits, I have double every other, and I'm using list comprehensions. But so we talked about the kind of basic logic of this is a pipe, it's a pipeline, right? So the output of one function is the input of the next function. So it's just like going down the line, getting processed kind of one function at a time. So functional programming is a different paradigm from object-oriented programming, but we'll use elements of both. And this compose function is an example of kind of a basic, it's a higher order function that you could use in a functional programming style. So all of the, let's say the basic functions are the same, essentially. So, but instead of creating, instance variables or whatever, we're just returning it. So these are all pure functions. And then what's happening here is that we're basically saying, here are all the functions that we want to execute, in this particular order. And then when we actually run them, we pass in all of these functions and decompose. So you can think of this as a pipeline, right? It's going to do reverse digits and then double every other and add digits and check modulus. And you might, one of the reasons people like functional programming is because it's less imperative and operates at a little higher level. So you can kind of look at this and just see, okay, so you reverse the digits, then you double every other, then you add the digits, then you check the modulus. So it's kind of easier to read. But here what we're doing is we have this, so I wrote this compose utility, and it's a higher order function. So it both takes in functions and returns a function. So either one of those things would make this a higher order function. This does both. And then what we do is right here, we're basically priming this. So there's something called currying or partial application, which if you're interested in functional programming, we don't really go in depth in Platoon and functional programming, but if you're interested, this uses something called currying. So we're kind of prepping, we're kind of pre-applying this parameter here. So it's like preloaded. And then when we execute this digits, this parameter here is this argument right here. And then we're looping over and we're saying, we're going to call first reverse digits, right? So for func and funcs, so we're going to call, this is the first time this will be reverse digits, and this argument will be whatever that initial string is, right? So this will return a value. So reverse digits, it returns this array of reverse digits. So arg will now be an array of reverse digits. Then it loops over again to the next function, which is double every other. And it calls double every other and passes it that reversed array that we got from the previous iteration. And whatever that returns, double every other, it's this, array where every other one is doubled. Then that gets assigned to this, and it just keeps going on and on. So this works because we only have one parameter. So each function only takes one parameter, and then the input, the output of a given function is the input of the next function. So I just want to expose you to that. That's another. I have another paradigm. So we have an object-oriented paradigm, and then we have a functional paradigm. Are there any?
Chad, so if there's kind of these two schools of thoughts in programming, and we're mostly going to be learning object-oriented, can you just say a little bit about like why we're choosing to do that versus why somebody might want to go look at or study functional programming instead?
Yeah, so a couple of things. That's a good question. So one is that the dominant paradigm in the software industry is object-oriented programming. So in terms of like getting a job and being able to understand the majority of code out there, you need to understand object-oriented programming. So when we get to React, you can write components in either an object-oriented style or a functional style. And React is moving towards basically preferring a functional style. So when we get to React, you'll see more of the functional style. So the short answer is, why do we teach object-oriented programming? I'm not here to I don't really have a strong opinion myself, and I'm not here to sell one or the other. But you can see that, there are certain benefits and drawbacks to either. Well, one, if you do something like this, methods and data are packaged together. But I mean, is this violating, like a principle of, do one thing and do it well? Well, now this object is doing kind of two things. It has two things, as methods and data. Maybe that's bad. We're also, a lot of these functions are impure in the sense that they're modifying something outside themselves. It's within a class or an instance, but still technically impure. Whereas functional programming, it is a little easier to test. And then some people like just the style. Feel like it's more readable or intuitive.
Do you think most people would say functional is more intuitive and readable, or just people have their personal preferences of either one?
I would say it's more of a personal preference issue. I think people find functional programming to be fairly arcane and difficult. There's some concepts. So we actually have been doing functional. So it's something like map in JavaScript. I mean, this is a higher order function, for example. This is a functional programming thing where you have an abstract, you have a more abstract function that's kind of like a general purpose function. It takes in a function and does something specific. So it's less imperative, right? So if I use map in JavaScript or Python, I don't have to go through, like in a JavaScript for loop, I have to set this initial value, and then I have to check, okay, here's the condition, then I have to increment it, and then I have to tell it exactly what to do, and then do this. So it's just very do all these details. Whereas if you use map, it's just abstracted away. So it's more, there's this idea of declarative versus imperative. So imperative is, I'm telling you exactly what to do, every single detail, right? Like a for loop in JavaScript. A declarative is more just like, I want to run this function on every element that I give you. So if you use map, you're not bogged down in the details of assembling this for loop. So yeah, functional programming tends to operate at a higher level of abstraction.
And I just wanted to add, from my experience, if you work at a company that has an Oracle environment and they use Java, object-oriented programming is going to be good to know. Or if they have a Microsoft environment, which a lot do, C# is object-oriented. So it's good to know for those languages too.
Yeah, I don't know what the official stats are, but I would guess that 90, I don't know, 80, 90% of the jobs that you'll working are going to be using that paradigm, maybe more. Okay. If there are no